Application of trigonometry in engineering.
Good morning, my name is Allister I'm from class DTK1B. Today I will be explaining what is application of trigonometry in engineering. Trigonometry, originally the study of triangles, has found numerous applications in modern engineering. Start by giving a quick history of trigonometry. You could mention that trigonometry originated from the study of the relationships between the sides and angles of triangles. This ancient field of study has been around for thousands of years, with contributions from mathematicians like Euclid, Ptolemy, and Al-Biruni. While trigonometry started as a simple study of triangles, its application extended far beyond. Today, engineers across various disciplines use trigonometry principles to solve complex problems, from designing stable structures to analyzing electrical circuits. Consider the construction of Eiffel Tower, a marvel civil engineering. Trigonometric calculation was essential for determining the angles and mass of the iron grinders used in its constructions.
Introduction to basic of trigonometry.
The trigonometry is derived from Greek words meaning triangle measure and studies relationship between side and angles of triangles, especially right angle one. Side, the ratio of the length of the side opposite to the angle in consideration to the length of the hypotenuse in a right angle triangle. Cosine, the ratio of the length of the side adjacent to the angle in consideration to the length of the hypotenuse in a right angle triangle. Tangent, the ratio of the length of the opposite side to the length of the adjacent side in a right angle triangle. Right triangles and Pythagorean theorem. It introduced the Pythagorean theorem, which is a fundamental relation in Euclidean geometry, stating that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other. The squares of the other two sides is a squared plus b squared equals to c squared. Practical example, it provides an example of how trigonometry can be used in real life scenario. A hiker observing the peak of mountain from a certain distance can determine the height of the mountain using the angle of elevation and trigonometry. Summary, emphasize the importance of understanding these basic trigonometric ratios and relationships as they serve as building blocks for solving more complex engineering problems.
Today we are diving into an interesting intersection between mathematics and engineering. How trigonometry helps us solve real life engineering problem. Let's consider our problem of optimizing solar panel angle to maximize its efficiency. Solar panels are most effective when they are directly facing the sun. But what angle should we use and set at? Here where trigonometry comes in. The sun position in the sky can be described using angle, and trigonometry function can help us calculate the most efficient angle for the solar panel at any given time. To solve this, we can use trigonometry function like sine, cosine, and tangent. Also, we can use a square plus b square equals c square and c square equal a square minus b square. This function will enable us to model the sun trajectory, thereby determine the optimal angle for our solar panel. By utilizing trigonometry to find the optimal angle, we can increase the solar panel efficiency and reduce the energy waste. Also, we can contribute to sustainable energy solution.
Let's search the best angle for the solar panel.
Okay, let's research. This is one of the question. We need to search this angle or theta. This is the solar panel, the sun. Okay, we also be given the length for this and this, A and B. For searching this angle, we need to use sin C per C equal to sin A per A. We already know this angle is 90 degree. But first, we need to search this hypotenuse by using these two given number. by using these two lengths. Okay. We'll already know A equal 382, B equal to search the hypotenuse we need to use the formula A square plus B square equals C square. Okay, A equal 382 and B equal 848 and C we need to set C, the hypotenuse. Okay. 382 is equal 382 square square. Okay, we open the calculator. We put the number 382 square plus 848 square equal 865,028. We copy this. We square root. We paste the answer. And we square root this, and we got 930 for the length of the hypotenuse. 930 for the length of this. We can use the Fusion 360 already. Fusion 360 can detect this. Okay, we double check it, and here 930 millimeter. You can look it and measurement 930 mm. Okay, we will use the sine rules for determine the angle for this solar panel. The most efficient angle and effective angle. I already solved it. As we see the answer, here it is. You can see sin C. Okay. Sin C per C equals sin A per A. Sin C, we don't know. Here is the sin C. And the length is 382. Here and here. This is C. This is also C. Angle C and length C. Here sin A equal 990 degree. Here 90 degree. And the length for A is hypotenuse. The hypotenuse here 930. We already solved that before. Okay. Sin C per 382, the length of C here, the length here C equal sin A 90 degree per 930. Sin C equal 382. We take this and put it here. Sin 90 equal 930. We solve this and we got this. Sin become sin -1, and we use the calculator and we get this answer to 24.25 degree. And let me check using the software. Already integrated measurement here. You can search here and here. What is the angle? 24.3, or the more accurate here, through 24.25 degree. Let's we adjust. Now our solar panel only 0 degree. We adjust to 24.25 degree to get the most energy from the sun. Yeah. That's it. Okay, thank you.
Conclusion.
In conclusion, we have explored how trigonometry, a mathematical field born from study of civil title, has found a diverse and complex application in engineering, from structural art, electrical to civil engineering, trigonometric principle, and principle. As technology continues to advance, the foundational principle of trigonometry remain as just relevant with its design or cutting-edge structure. The electric circuit in renewable energy system are appreciated in land surveying. Trigonometry in a cornerstone in engineering problem solving. As the saying goes, mathematics is the language with which God has written in the universe.
and engineering trigonometry is one of its most elegant projects.